What we saw in the last segment was that the graph was a parabola, and that leads us to the equation, the position equation. Now, the equation of a parabola is y equals ax squared plus bx plus c. And what we've seen previously is that when we line these equations up with each other with the equation for an object experiencing constant acceleration, is that this c is the starting position, the b is the starting or initial velocity, and this coefficient in front of the x squared is 1/2 the acceleration. And that expression we should write and think of as being capital A equals 1/2 little a. So solving for little a, the little a is twice that coefficient big A. So if we then have data like we saw on the last slide, where we had this equation that came about from the data, we can look at that equation. And all I did is I reversed the order, because if you remember, the computer will put these in the opposite order, where this is C, this is B, and this is A. We want to reverse the order of those so it more matches our understanding of a parabola, and I did that for us. Well, what that means then is that this 1/2 A is this negative 4.9. And this negative 1.77 times 10 to the minus 15th is the V0. And this 1.15 times 10 to the minus 15th is the Z0. Let's first deal with these numbers that are times 10 to the minus 15th. If we write out a number that's times 10 to the minus 15th, here's our decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What you can see is this number is extremely tiny. This number is trying to be 0. And since this number is also 10 to the minus 15, it is also trying to be 0. So effectively, this equation, z equals minus 4.9 t squared plus 0t plus 0, and those terms drop out. Now, you may say, like, sometimes there might be a number that will be really small and it will count. How we know is that this number times 10 to the minus 15 is extremely small compared to this number. If this had been negative 4.9 times 10 to the minus 14th, then these numbers would be all this number and this number and this number would be all about the same size, so they all matter. But because these are so tiny in comparison to this, they have almost no effect. So ultimately, we're looking at this equation, z equals minus 4.9 t squared. Well, what that means is negative 4.9 is 1/2 the acceleration. So negative 4.9 equals 1/2 the acceleration, and therefore the acceleration is twice minus 4.9, and that means it is negative 9.8 meters per second squared. And that is the position equation, how it connects to the general form of a parabola, how to interpret the coefficients when we have data, and it gives us a trend line.